Special factoring. We're first going to look at the difference of squares rule. Here we have x squared minus y squared. That factors into the quantity x plus y times the quantity x minus y. This is the difference of squares because our first term x squared is a perfect square. Our second term y squared is also a perfect square, and it's separated by a minus sign. Minus meaning difference, so we have the difference of squares. So let's look how this works in example 1a. Here we have 4a squared minus 64. As is true in all factoring problems, our first step is to remove the GCF, in this case 4. Now once we've removed the 4, we look at our remaining factor, the a squared minus 16, to see if it fits our rule. Our first term is a perfect square. A times a gives us a squared. 16 is also a perfect square, 4 times 4, and they're separated by a minus sign. So we're going to copy down the 4, that's our GCF, and now we're going to use this pattern to factor the a squared minus 16. A times a gives us the a squared. The 4 times 4 gives us the 16. Now if you look at our pattern, one of our factors has a plus sign and the other a minus. Order does not make a difference. So our final answer would be 4 times the quantity a minus 4 times the quantity a plus 4. Our next example, 16m squared minus 49p squared. Our GCF is 1, so we can move to our second step. Our second step is to determine whether or not this is the difference of two squares. 16m squared is a perfect square, 4m times 4m, and 49p squared is also a perfect square, 7p times 7p. So we can use our pattern to factor. 16m squared, we said, was 4m times 4m. 49p squared is 7p times 7p. And remember, one of our factors is plus and our other is minus. So our final answer is the quantity 4m plus 7p times the quantity 4m minus 7p. Our next example, x to the fourth minus 81. So we ask ourselves, is x to the fourth a perfect square? The answer is yes. Anytime we have an even exponent, that is a perfect square. 81 is also a perfect square, and they're separated by a minus sign. So we factor this using our pattern, x squared and an x squared, a 9 and a 9. One of these is a minus and the other is a plus. Now we're not necessarily done, because if you notice in our first factor, the quantity x squared minus 9, this is a perfect square again. And the difference of two squares we're going to factor again as x plus 3, x minus 3. Now the second factor, that x squared plus 9, is not the difference of two squares because of the sign in the middle being plus. So we cannot factor that any further. So our final answer is the quantity x plus 3 times the quantity x minus 3 times the quantity x squared plus 9. Our next example, 81k squared minus the quantity a plus 2 squared. Our first term is a perfect square, 9k times 9k. And our second term is also a perfect square, a plus 2 times a plus 2. So now when we factor it, we follow our pattern. So 9k times 9k. Now I'm going to use parentheses, a plus 2 and a plus 2. And one's a plus and one's a minus. Now I'm going to have to remove my parentheses. So I still have my 9k, and remember, anytime there's a plus sign in front of parentheses, we just drop the parentheses. So that gives us our first factor of 9k plus a plus 2. And remember, when there's a minus sign, it tells us to take the opposite of everything inside the parentheses. So this becomes a minus a minus 2. So our final factored form would be the quantity 9k plus a plus 2 times the quantity 9k minus a minus 2.